Now we're going to look at simplifying rational expressions. You may find it helpful at times to take a graph that you're trying to find the shape of and find the pieces that will reduce out, the factors that reduce. So that's what we're going to practice here. We have 7a cubed over 21a. If we were to think of this as factored, we could say 7 times a times a times a in the numerator, and 3 times 7 times a in the denominator. What we're doing, and what we're hopefully doing in our heads very quickly, is reducing the common factors. So the 7 in the numerator would divide with the 7 in the denominator because that is equal to 1. And the a in the numerator would divide with the a in the denominator because that is also equal to 1. A over a is equal to 1. And so whatever is left is the product in the numerator and then the denominator. So we have a squared over 3 as our final answer. Now this next question is a similar idea. I know that 8 factors to 2 and 4. I know that 12 factors to 3 and 4. And I have these rules for exponents. I know that if I have a power or a list of numbers in the numerator, y to the 5th means y multiplied to itself 5 times. And y to the 9th means y multiplied to itself 9 times. So I need to reduce out the common factors. The 4 will divide out, and 5 y's will divide out. There are more y's in the denominator. There's actually 4 more y's in the denominator. So we can rewrite this as 2y to the 5th z to the 3rd over 3y to the 9 z to the 4th. Now keep in mind that when you're reducing fractions like this, the side with the smaller number is the one you're going to subtract. So let's try that. We would have 2 in the numerator. Y is the bigger number exponent-wise, so we would have y to the 9 minus 5. Think about that for a second. If you reduce out 5 y's, how many are going to be left? 4. But the 4 y's will be in the denominator, which is what happens. That's why I put y to the 9 minus 5 in the denominator. And then z is bigger exponent-wise in the denominator, so I'll have z to the 4 minus 3. Don't forget that 3 in front. And now let's see what happens. Well, we can reduce this. We'll have 2 over 3 y to the 4 z to the 1st. So you don't write an exponent on that one. Let's do the same thing again. We have 15 in the numerator, 25a minus 30 in the denominator. I'm going to factor out a common factor in the denominator, and hopefully it will reduce with something in the numerator. It looks like there's a common factor of 5, which will give me 5a minus 6. That will reduce with the numerator. I have a common factor of 5 in both the numerator and denominator, and I'll be left with a 3 in the numerator. This will give me 3 over 5a minus 6 in the denominator. Let's take a look at 4y minus 20 all over 4y plus 12. As it is now, you cannot just cross out the 4 y's because 20 is being subtracted from the first one and added to the second one. So it's not equal to 1. This would be like saying if you have, let's say 8 minus 20 over 8 plus 12, you get negative 20 over 12, and that's not true. So you have to factor out the common factor, or GCF, first. So my common factor is 4 in the numerator and the denominator. When I divide that 4 out, I get y minus 5 and y plus 3. Now notice, since the numerator and denominator both have a factor of 4 in common, I can reduce it out, and I'm left with y minus 5 over y plus 3. Now let's look at the last one. Write the simplified form for the following. Be sure to list all restrictions on the domain. Well, we have the function f of x is equal to x squared minus 25 over x squared plus 10x plus 25. I have this feeling that these will both factor, the numerator and denominator will factor, and then something will likely drop out. So now we have to remember all the factoring rules from before. X and x plus 5 minus 5 because we want our middle term to drop out. For x squared plus 10x plus 25, it looks like we need an x plus 5 and an x plus 5. Now it's obvious to me that we have an x plus 5 as a common factor in the numerator and denominator. It's multiplied to the other factor, and so we can then reduce it and say x minus 5 over x plus 5 is our reduced form. We need to list all restrictions on the domain. The domain of this function, we could say, is negative infinity. Don't forget to set your denominator equal to 0. And after I do these a few times, I realize that I can just set that equal to 0 in my head, and I know that x, the vertical asymptote, is at x equals negative 5. So this is the restriction on my domain. So I can say the domain is negative infinity to negative 5, close paren, union negative 5 to infinity, close paren.